So we authenticate, we go through your, or we authenticate through your net ID basically. So you don't have an HPRC password, it's going to be your howdy password. And remember, don't write these passwords down, don't choose easy to guess or crack passwords, and change your passwords frequently. Okay, so accessing a remote Linux system. Because we're working remote, we've basically been working remote for a little over a year now, a year and a half because of COVID. It's changed the ways that we work a whole lot. So now when you're working remote in a Linux system, you're going to use a protocol called SSH. SSH, it's a program which allows for remote access. You can think of SSH as connecting your computer, logging in from your computer to a Linux computer somewhere else. So in the terms of HPRC, Grace and Terra are computers that you don't physically have access to. You can't go sit in front of Grace and like put a monitor there. So you need to use SSH, which I'll show you in a second. You need to use SSH from a terminal, from a Linux terminal, to create a tunnel to Grace or Terra, or whatever Linux system you're using. And then that tunnel gives you a terminal, and then the terminal, you could type in all your commands. If you don't want to use SSH, you could use the portal. We're going to be using the portal, or I'm going to demonstrate how to use the portal, and then I'm going to use the terminal because it's easier for me, but whatever is easier for you guys. So if you want to use the portal and you have an HPRC account, this is the URL you're going to go to, portal.hprc.tamu.edu, and log in with your HPRC account, aka your net ID and password. So this is what the portal looks like. When you go to that address, portal.hprc.tamu.edu, you'll hit a page like this. On one side, you have the Terra portal, and then the other side, you have the Grace portal. It's pretty self-explanatory. You click on the cluster that you want to log into. And then here's the note again. You must be connected to TAMU Wi-Fi or VPN to even reach this page. If you're on campus anywhere, you should be fine. As long, I'm pretty sure it's just like you just need to be on TAMU Wi-Fi. If you're off campus or out of town or somewhere that's not the College Station campus, use the VPN. I'm sure you guys are very familiar with the VPN by now because we've been doing remote for a while. So once you click on the cluster that you want to access, in this case, I've clicked on Terra over here. At the very top, you'll see this banner, and the banner is where you're going to want to look, and you'll see files, jobs, clusters, and then shell access. So shell access will actually start an in-browser SSH session. So you get a convenient shell access anywhere that has a web browser, mostly anywhere. You probably couldn't do this on your smart TV, but anywhere that you would reasonably have access to, like a web browser. It's really nice because it's cross-platform. So accessing a Linux system from a Windows computer is different than doing it from a Mac computer. So no matter what kind of computer you're working on, you can always use the portal. So again, that's portal.hprc.tamu.edu right here. And then clusters, shell access. And then obviously the Grace one it's the same deal. It says clusters and then it'll say Grace shell access. Okay, so with that out of the way, that is how you connect using the portal. This is how you connect using SSH. So if you have a Linux computer already, you can type in this command right here, SSH -x. This is going to enable graphics, so you can run graphics remotely. That just means that if there's a graphical application that you want to run on the computer, on the remote computer, you can run it there and then send the graphics to your to be displayed on your local computer. This is the syntax: SSH -x, and then your net ID, and then the @ and then the host name. So in this example, this person says, I want to SSH connect to Dylan or net ID at terra.tamu.edu. This is the host name. So Grace is going to be grace.tamu.edu. Terra is going to be terra.tamu.edu. If it's your first time connecting, you're going to see this message right here. And this is basically just saying, hey, you've never connected before. Are you sure you want to connect? You just say yes. And then it's going to add the host name to your list of known hosts. And then you enter your password. So in Linux, whenever you're prompted to enter your password in the terminal, in the command line, most of the time, you're not going to see any sort of any sort of like visual input, you're just it'll just be blank like this. So let me show you an example of what I mean. So if I have a new terminal, and then I say SSH Dylan at terra.tamil.edu. This is going to log me into Terra. And now this is like the warning that says this is a state computer. Don't use this computer for anything bad, I suppose. And then it prompts for your password. So as I type my password in, it's reading my input, but it's not showing me anything. And then when I hit enter, it accepts my password and then asks me for Duo. Oh, I'm only showing the slides. Okay. Good catch. Good catch. 1 second. Let's do this real quick. Sorry about that. Desktop. Okay. So here's my terminal, and I'm going to SSH into Dylan at terra.tamil.edu. And this is what I meant before. It gives me this warning that says the computer system and the data herein are available only for authorized purposes, blah, 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 blah. At the very bottom, we have the password. And as I'm typing in my password, it's reading my password, but it doesn't show me any little asterisks or like input that says I'm typing in anything. But when I hit enter, oh, I typed my password wrong. When I hit enter, it accepts my password and then prompts me for Duo. So a lot of times people who use Linux for the first time and they SSH in, they're like, oh, it's not reading my password. It is reading your password, it's just not showing you anything. And then obviously you could just Duo push yourself onto the cluster. There we go. So I'm logged into Terra. Okay, clear my screen. Again, to use the HPRC clusters, you must apply for an HPRC account. So I kind of figure if you're here, you have an HPRC account, or you're going to apply for one. If you don't have an HPRC account, don't worry. The commands that we're going to talk about after this are applicable to all Linux systems everywhere. So don't worry if you don't have an HPRC account. So let's talk about the very first command that you should learn. The very first command, super simple. It's called pwd, and it stands for print work directory. So you should have a Linux terminal open somewhere. If you're working from your browser, you could be in the portal and then open up Terra, and then open the shell access from Terra. If you're working from your local computer, like you're not using your browser, open up a terminal somehow. If you're on Linux, open your terminal. If you're on Mac, like I am, you could just hit Command space and then terminal, and that'll open up what I'm working with right here. So the first command, pwd, all it does is it returns your work directory. So when I type pwd, it says I'm in home Dylan. So by default, when we log in or when we launch a shell, we're put into our home directory. So here's what this kind of this slide will demonstrate. The commands are going to be in green, and then the output for the commands are going to be in blue. So now that you know how to print where you are, you could print what the contents of your current location are. That command is going to be ls. So you could think of ls as list. So if I say ls and hit enter, I see some stuff. I see contents of home. I see crlf terminators, this directory right here. I see this script, another directory. So you'll see I have some output, and then this output is different colors. We're going to learn about that later. Okay, so finding your way around the Linux directory structure. The Linux system is organized as a tree, specifically an inverted tree. It's upside down. So at the very top, we have the root directory. And those are all top level directories. For newer users, you'll probably never go into these, at least right now. There's a lot of configuration files, a lot of log files. Whenever you install software in a Linux system, it's going to use these top level directories to store application files and configuration files that it'll probably use later on a system-wide basis. Other than that, you have the home directory, so the very top home directory. And inside that directory, you have all of the users' home directories. So inside the home directory, we see Sarah's home, we see Chris's home, and then in this example right here, it shows inside Chris's home, we have Chris has docs and scripts. So obviously this can get very, very, very long because Chris could store whatever he wanted in here and Sarah doesn't have anything in here right now. And then we also see we have var. Var also has two subdirectories in it, log and www. So the takeaway from here is think of Linux as a tree, an upside down tree. The very top level directories have operating system configuration stuff, which you probably will never need to work with unless you have like a Raspberry Pi and you really want to tweak it and play with it. That's something you could do, and I recommend if you really want to learn about Linux, get yourself a really cheap like $30 Pi and just kind of go to town on it and see what you can break. It's pretty fun. The other takeaway is the home directory has everyone's home. The home directory has everyone's home directories, and it's where you land when you first log in. So anytime you turn your computer on, if I turn my Mac on and I say, okay, open the terminal, it's gonna drop me in my home directory on my Mac. Okay, so Linux commands have options. So you can leave a space between a command and the option is going to modify what the command does a little bit. It's gonna modify the output of it. It's your way to really refine each of the commands that you'll learn. So again, the second simplest command is ls, which is list. So we see this ls command, which is the base command, and then we see the flag after it. So the double dash means that this is a single option, which is usually a descriptive word. So when you see two dashes, you can read this entire option as one word, and that's how Linux is going to interpret it. So this is saying list all the contents. So when we listed before, you might ask yourself, well, what else is there if we didn't list it all? It's basically hidden files. Hidden files are files that begin with a period. Why would you use a hidden file? Typically you won't, but some applications will. So a good example is if you're making an Anaconda or a Python environment, the actual files that are inside the environment are stored in your, well, it's stored in the directory wherever you tell it to store it. Well, let's just say home for simplicity's sake. But all those files are created with, they're hidden. So they begin with a period. Because whenever you type ls, you don't need to see all of the source code for your environment. That would just be really, really messy. So it gets hidden. Sometimes you might need to see it. And in that case, you could say double dash all. But the cooler way to do that is to use the single dash. So the single dash means that each character is an option. So again, double dash means interpret this entire string as one option. Single dash means, okay, each character is going to be an option of itself. So again, ls is the base command. Now we're saying -a -l. So a little different here. Let's try these out. I'm going to Control L to clear my screen and say ls double dash all. And it takes a little longer because there's a little bit more files. So we see a Java, a Keras, .local, .fluxbox. I'm not sure what that is. There's the .conda, .cache. So these are all hidden files that were created probably by the application that it's named after. So like MATLAB made this one, Mozilla made this one, Java made that one, etc. You get the point. So that was with the double dash all. So if I say, I'm going to Control L to clear my screen and say ls -a -l. So now we see these hidden files again, but they're in a little bit of a different format. So this format here, I'm going to make this full screen. This format here is called the long list format, and this was given to us by this L flag. I personally prefer this long list or vertical format compared to the traditional like horizontal ls format. So on our clusters, we have an alias that says whenever you type ll, we're actually going to translate that into ls -l. So this output that we just ran right now was ls -a A minus L. So if you remove the minus A, you're still gonna have this vertical long list format, but you're not gonna have the hidden files. So by deduction, we can assume that minus A, ls minus A says, show me all files including hidden files. That's correct. So I see the hidden files here. And then the minus L flag says, show me all files in a long list format. So if you want to see all files, including hidden files and the long list format, you need L and A. There you go. So, and that's detailed on the side here. Now, most options can be combined behind one dash. That just saves a lot of time. So ls minus minus A minus L is the same as ls minus AL. So again, the big thing that we're looking at here is this single dash. The single dash is saying every character is an option, whereas the double dash says, okay, everything here is one option. So this would interpret AL as one option. I don't think AL is an option, so it would throw an error. But the single dash means every character is an option. Yeah, so a lot of times in Linux, you will see people using Linux commands with tons of options and flags. Oh yeah, I also forgot to mention, options are the same thing as flags. So if you hear me say flag or an option, they're the same thing. There's kind of no real consensus on what they should be called. I think like the technical way to refer to it is an option, or is it a flag? It's one of the two, but they're interchangeable. So flags are options, options are flags. You'll always see them. So whenever you see a Linux command and then a dash, just know that whatever comes after the dash is an option. So I guess your next question would be, how do I find these options? Well, the best answer is always Google, but I will show you the Linux way to do it. So the Linux way to search for options is to use the man page. Man stands for manual, and it's about as enticing as reading your microwaves manual. It's very, very detailed. Sometimes it's so detailed, it's like, I didn't need to know all of that, but thank you anyway. So most Linux commands are gonna have a man page. To access the man page, I'm gonna Control L to clear my screen. You can say man and then the name of the command. So I'm gonna say man ls, and it's gonna open up the manual for ls, and it tells me everything I could ever possibly need to know about it. The name of the command, list directory contents, a synopsis of how you should use it. So this says you call the command and then you give some options, and then you can optionally give a file. So this is if you wanted to say, okay, show me the contents of this this item, but the file has to be a directory. Kind of misleading, kind of misleading there. So to actually print the contents of like a text file, that's a different command. We'll talk about that in a second. But ls is use ls on directories. So ls directories to list their contents. And then, yeah, here's a description of all this stuff. And then you see all of the flags. So here's the -a flag. And you'll notice that the -a flag has a comma, and then it says, or you could say $all. Both of these things are going to accomplish the same thing. And they're going to say, do not ignore entries starting with period. In other words, show me hidden files. There's also -A or almost all. Whole bunch of stuff there. Yeah, so like I said, these are going to be all the flags that you could use. It's probably better to go to Google. Google will give you more concise information, and it's probably easier to search. When I started learning Linux, Google was my best friend. So if you needed to find a flag for a command, I'd highly suggest just going to Google. It's so much easier. If you're in the man page, man ls, to exit the man page, sorry, I just kind of left y'all hanging there. It's Q. So you hit Q on your keyboard, and it's gonna return your prompt to you, just like that. If you ever get stuck inside of a Linux command somehow, the two ways you can escape are always try Q. Q might work. If Q doesn't work, Control C. Control C is the it's the interrupt. It's the signal interrupt. It says, "Hey, stop what you're doing. Kill this process. Give me my prompt back so I can type." Okay, I'm gonna Control L to clear my screen.
Dylan, there's a question in the chat for you.
Let's see it.
Can we log onto Terra using Xshell in Windows?
I believe you can. I don't have a Windows machine. Oh, so, okay, the question for the people in the room was, can we log into Terra using Xshell in Windows? So the answer to that is, I believe you can. I think that's what we did, Drew, in the summer camp.
Yes, that's what. Oh, sorry, I don't have a Windows machine either.
Yeah.
But we were able to log in. It's got an SSH part, and that can be used.
Okay, so in the chat, they're talking about connecting using from a Windows machine, and the answer is yes. I think you open up your PowerShell or Xshell, you can just SSH directly from there. I would recommend, though, if you have a Windows machine, to download MobaXterm. MobaXterm is an SSH application. It's free, and it comes with a whole bunch of other features built into it. It's as easy as, like, you click session and then you type in, I want to connect to terra.time.edu, and you put your net ID and password, or you put your net ID and then it prompts you for your password. MobaXterm is the go-to for Windows SSHing. If you're on a Mac, you can just use your terminal. If you're on a Linux, also you could just use your terminal. But to answer your question, I believe it's possible, although I would recommend MobaXterm. Good question, though. Good question. Question?
Just we can use as extension Windows, and I can use it again.
Yeah. So the question in person was, one of the users is it the Ubuntu subsystem? Yeah. So he has the Ubuntu subsystem installed on his Windows 10, right? Yeah. On Windows 10, and he can SSH from his what is it, terminal? Like what's Gotcha. So he's saying you can just type in Ubuntu in the start menu, and it'll open the shell, and then you can from right there you can SSH in or type these commands in, and you should be good to go. Oh, so Dan has a question. Would you recommend WSL, the Windows subsystem for Linux, from the Windows App Store combined with the Windows terminal? Yes, Dan. So I think one of my colleagues here, she used the WSL for a long time too. She had like a Surface Book, and then when they announced that application there, she used that primarily. That also is an acceptable solution. It's really whatever you're most comfortable with. I think the reason I suggest MobaXterm is because most of our users are just more comfortable with going to a page, downloading the application, and being done with it. But if you're comfortable using the WSL on Windows 10, then yeah, totally acceptable solution. Good question. Thanks for bringing that up. Okay. So let's talk about some common directory commands. These commands are very simple, and also these commands also, like, the way the name of the command kind of implies what they do. So it might be really, really simple when I talk about it, but you're gonna want to try to commit these to memory because they're the bread and butter of kind of moving around and working in Linux. So the first one is mkdir, which is the command to make a new directory. So to our terminal we go, and I'm gonna say mkdir Dylan directory. Let's make it more simple. Whatever. Dylan directory. So when I type that, one thing about Linux is that whenever you type a command in, Linux is going to do exactly what you tell it to do. So in this case, this is a very simple command. It says make a directory and name it Dylan directory. When I hit enter, I don't see anything else from the terminal. It just gives me a new line. So that's telling me, by its silence, it's telling me that it ran correctly. If there was an issue, such as an invalid command, like, so if I said make dir with 2 R's and then Dylan directory, I get some output that's not silent, and it says bash had an issue, and the issue came from this command, make dir, and the issue was command not found. So that's the syntax that you'll see in Linux. Specifically, this is called bash, the born again shell. Again, shell is this terminal that we're working in. So that's kind of the language that we're using here to interface with Linux. So interfacing with Linux, bash says, I didn't understand what you meant by Mkdir. And the reason I didn't understand it, or the reason I had an issue with it, is because I couldn't find that command. And then it says, okay, similar command is Mkdir. Maybe you had a typo. So sometimes it'll give you a similar command. Sometimes if you're really far off, it'll just be like, yeah, good luck. I don't know what you're talking about. But here we've made the Dylan directory. So let's type ls. And now I can see it's right here. It's blue because it's a directory. So on my screen, the colors are a configuration thing that you determine on your own. This is kind of like a very standard practice configuration where you have directories listed as blue, directories again being folders in Linux. Green are going to be files that are executable. So it's either it's a script of some kind or some kind of executable program that you can run. White is just text. It's just a file. So contents of home.txt is it's a text file that, I don't know, it has the contents of home, I suppose. And then lastly, red is an archive. So it's a bunch of files glued together. Think of it as a so like in Windows, when you like zip a file, you're actually compressing it. In tar, you could group a bunch of files together and put them, you typically group them together and then compress them. This one doesn't seem to be compressed because it doesn't have a .gz or a compression extension. So by this name and its color, I can assume that it's we call them tarballs because it's a bunch of files all grouped together. And we're going to show you how to create them and extract files from them towards the end of the class. So mkdir made Dylan directory. That's what we were going for here. So now that we made it, let's move into it. So the command that you will use the most, in addition to ls, is going to be cd. Cd stands for change directory. So to use it, you say cd and then the name of the directory that you want to move into. So whatever you type right here, Dylan directory, this is going to have to be blue. You can't move into a text file. That doesn't make sense. You can only move into a directory. So when I do that, my prompt changes and it says Dylan at tlogin0501, those squiggly / Dylan - directory. So this is telling me, okay, I'm now inside the squiggly and then Dylan - directory. The squiggly line right here represents the squiggly, come on, the squiggly tilde equals /home / $user. So it's a variable that always points to your home directory. So whatever your user name is, it's gonna reflect there. So it's just a shorthand for saying, okay, inside Dylan's home, he's inside Dylan's directory. So now to move out of here, I could either move down another level by saying cd and then the name of some folder. That would take me down one level. But there's no other folders here. If I type ls, nothing comes out because it's an empty folder. So I don't want to be in an empty folder. That's very lonely. I'm going to move up one. If I do cd and then space ... that takes me up one directory. And now I've left Dylan directory and I'm back in squiggly. So again, cd and then the name of a directory that you want to enter will put you in that directory. And then to move up one level, remember it's like an inverted tree. So just up one level is cd ... So ... is another variable similar to the squiggly. However, this one's relative and it's always going to point one directory level above where you are. So if I was let's see if I make a directory inside of Dylan directory called another one, and then I cd into Dylan, and then I cd into another one. Now I'm in squiggly Dylan directory and then another one. And if I want to move up once, I could do cd ... But if I want to be a cool programmer, I can move up 2 at a time and say cd ... /... And that's going to move me up one directory and then up another directory. And I'm back home. I'm going to clear my screen. And we're going to move on to Rmdir. Rmdir is to remove a directory. ls one time to see the contents of this folder. I see Dylan directories here. It's lonely and empty, so let's remove it. Rmdir, similar to Mkdir, this is going to remove it. And then I give the name of the directory. And this is actually going to throw an error. So Rmdir can only be used to remove an empty directory. So just for demonstration's sake, I'm inside Dylan directory, and now I want to remove another one that I just made right here. So Rmdir, another one. And because another one is empty, I don't get any errors. Linux doesn't complain to me. And if I ls one more time, I could see that it's gone. So now if I want to cd ... to move up, I can ls and see that Dylan directory is there. And now let's remove that, Rmdir Dylan directory. Okay, so now we've gone over making directories, moving around directories, and creating directories, deleting them, and moving around. So Linux terminal attributes, we talked about this. Green is executable stuff. Teal or turquoise, whatever you want to call this color, those are symbolic links. I really wouldn't worry about those right now. Just kind of know that they exist. They're basically pointers. So if you see something that's teal, it means that this is pointing to another file. Green are executable files. Red are compressed files or archived files. Purple are image files. So your media, like if you have a JPEG or a PNG or an MP4, I think like a movie, it would be purple. Blue, white, and green are going to be the ones that you look at the most, either executable files. Blue, again, are directories. So those are going to be folders. They contain other stuff. And then white are just plain old text files that you can print the contents of. Okay, so changing directories with the cd command. We're going to go over this because it's very important to note to get comfortable moving around. So let's move to our home directory. To move to our home directory, we can say cd from wherever we are and hit enter. And that's just going to always take us back to our home. So you know you're in your home because you see this little squiggly and that's all you got. It just says squiggly and then the $sign. So that says we're in our /home/user. So from here, we're going to run these commands. So we're going to say mkdir, what's it called? Temp. So that makes a directory called temp. And then we're going to do mkdir again and say temp/hg19. So this is saying make a directory inside of the temp directory and name it hg19. And then we're going to say cd temp. And now pwd. So again, we use cd by itself to go home. Once we're in our home, we said make directory temp, and that made the temp directory inside of our home. We said mkdir temp/hg19, which made the hg19 folder inside of our temp folder. And then we moved into our temp folder. So now we're about one level down. And then we print our work directory. So over here we see Dylan, home Dylan temp. And now we can move another level down by saying cd hg19 and pwd that. So we see home Dylan temp hg19. And now we're going to use that super cool programmer technique that I told you, and we're going to stack two dots together. We'll say cd ... /. So that's going to move us from this directory that we're in up into temp and then back up into Dylan. Enter. And sure enough, we got our squiggly back and we've moved up 2 directories. So now we're going to introduce another sort of variable character, and that's going to be the dash. So if I say cd dash, just the dash, that's going to take me back to back to my previous work directory. So it didn't just move me down into temp, it moved me back down into temp and then back down into hg19. So it's kind of like the back button on your browser. If you're working deep inside of one folder and then you need to transfer over to another folder and then move back to where you originally were, the dash is going to be your friend. And again, that's just cd dash. Okay, so after our dash, we could pwd, and it shows us that we're in HT19. We could cd dot dot, pwd again. We've moved up one because we only did one dot dot. And I believe we just cd again, that takes us home. And then pwd confirms that we're home. So takeaways from here, dot dot slash dot dot moves you up twice because we're using two dot dots. And then the dash takes you back to where you previously were. So not necessarily, you don't have to just move one level at a time. You could move multiple levels and then use the dash to kind of get back to where you were. Okay, so now things are going to pick up just a little bit. Absolute versus relative path. So if you're in the project directory, this one that's bolded over here, home Chris project, then the relative path to the README file, so the relative path to this file is going to be dot dot, which remember brings us up, and then docs slash README. So the relative path is going to change depending on where your current work directory is. The absolute path is going to be from the top down. So from the very top root directory, where's this file? So one way you can kind of tell an absolute path from a relative path is the absolute path down here. Again, the absolute path through the README is going to be /home /Chris /docs /README. That's its absolute location on the machine. That's not going to change unless you move, unless you go into docs and then you physically, like, or I guess through the terminal, you know, move this file somewhere. As long as this file remains here, this absolute path will always point to it. A way to tell an absolute path from a relative path is the absolute path starts with the slash. So when you're starting with the slash like that, you're saying, okay, from the top down, from the root directory, take me from the root directory into home, into Chris, into docs, and then into README. That's the difference between absolute and relative paths. While you're just starting your Linux journey, I would recommend you use absolute paths, especially when you're giving commands that are going to operate on some file, because you want to be absolutely sure that you're going to be pointing at, you want to make sure you're pointing where you want Linux to work. Once you get more comfortable in the system, you can start using relative paths, but it's probably easier to just give the entire absolute path while you're just starting off. And then as you get more comfortable, you could switch to relative paths. So again, the relative is going to change depending on where you're currently standing in Linux, your work directory. And then the absolute path is going to be the complete address of the file, folder, whatever you're working with. Okay, the history of your commands. So your commands are saved to a file in your home directory called .bash history. It starts with the dot, it's a hidden file, it's always in your home directory. Again, that's .bash _history. You can use the up and down arrows to scroll through your previous commands. So in here, in Linux terminal, I'm going up on my keyboard, and I'm seeing all the commands that I entered. So again, all of these commands are saved in your home directory in a folder called, in a file called bash history. You could print the contents of that file really quickly anywhere. If you just say, all the way down to the bottom, if you just say history, it's going to print out your commands. I think by default, it's like the bash history saves like, is it 1,000? It might be 1,000 because this is at 1,045. It saves quite a few of your commands. So you'll have several thousand of your previous commands entered there. I know you can adjust that later. That's like a configuration thing that you can do. But your takeaway here is that the commands that you enter get saved. So if you ever enter a command that works, and then later on you come back and say, oh, where was that command? You could spend a lot of time tapping up through your history. Or you can just use history to print all your history and then scroll through it like this. Okay. This prints out your entire history. If you just want to see the last 10, you could say history and then the pipe operator. The pipe operator is on my keyboard. It's above the enter key on the right side. If I say history pipe tail, that's gonna, this pipe character here, it's an operator that says, okay, I need to, what we're gonna do is we're gonna use the history command, and then we're gonna send the output of the history command to the tail command. So you're kind of stacking two commands together. Now the tail command just takes as an input some kind of, it takes as an input a line of lines of text, and then only returns the last 10. So when I say history, it's giving me the entire history that I have, and then tail says, okay, thanks for giving me everything. I'm only going to return the last 10. So we see 37 through 46 here, and then it includes the actual command that I ran right there, history bar tail. That's called the pipe operator. We're going to talk about operators a little bit more, but that's kind of advanced, but you get a little bit of an advanced operator there. Oh, actually, speaking of advanced operators, this is a really good one. So to search your histories, your command history using the bar and grep. So grep is a regular expression search. So if you're computer science or you've done any programming, you might be familiar with regular expressions. They could be annoying and hard to work with. In grep, think of regular expressions as it's a string. It's a string that you want to search for. So if I say history bar grep, what do I want to search for? Let's search for MATLAB. Have I done anything with MATLAB? Let's find out. So this is saying, okay, show me the history of my commands, but only show me the lines that have something that that contains this word, MATLAB. Okay, I did. I loaded MATLAB and then ran MATLAB twice. So again, grep is how you search. You just need to provide grep something to search. In this case, we printed out the contents of my history and then searched it for MATLAB. That was using the bar command. Okay, speaking of operators, these are the rest of them. Now, we're not going to cover all of them because they can get pretty in the weeds, but you should just kind of know that they exist. Whenever we type in commands in Linux, by default, the output goes to our standard out. The standard out is like the technical word for this, your terminal. So this is where the standard output will get sent to. You can change where commands send output to. For example, you could redirect the output to a file. So let's say I wanted to run the history command and then send that contents to a file, and then I could send Rhythm that file because he wants to see my commands or something. You can do that, and you'd use these operators. Let's only focus on the top ones here. It's the less than, and then the greater than, and then the double greater than, the double less than. And then they do exactly what they say here. The big thing is that when you're sending output somewhere, if you use two greater thans, you're gonna append the output to the file. If you only use one, you're gonna overwrite the file. So again, the difference between appending and just writing to the file is if the file exists and has contents, all that contents are just gonna get overwritten by the new stuff. The double greater than will say, okay, add this content to the bottom of the file, or to the top of it. It appends it. It adds it to the file. I'm not sure if it goes to the top or the bottom. But yeah, and we're not going to talk about the bottom stuff. So attributes. So files have permissions on them, and these permissions determine who can interact with them. There's 3 permissions that each file has, and those permissions are going to be readable permissions, writable permissions, and execute permissions. If a file has the execute permissions, it's going to change the color to green. In my case, it's going to change the color to whatever your configuration is for an executable file. So those are the 3 permissions, and then there's 3 different categories that those permissions can fall into, and those are going to be the user, the group, and other. So the user is you, the person who owns the file. Let me show you an example by clearing my screen and then typing ls minus l. So ls minus l, again, is listing the contents in the long format. And the reason we want to do the long format is because we want to see this detail right here. This first column is going to be the permissions for this file. So this very first file right here, this very first row, I see it's called contents of home.txt. And here are the permissions. So we see RW and then a dash, RW and then a dash, and then R dash dash. So these 9 items right here, it's a group of 3 triplets, RWX, RWX, RWX. When one of the triplets is missing, that means you don't have the permission. And the order for the groups, or for the order for the triplets, is user, group, other. So the first 3 in this triplet right here pertains to the user. So this says the user has readable and writable permissions, but I don't have permission to execute it. There's no reason to have permission to execute it because it's just a text file. You can't execute text. I guess you could, but it doesn't make any sense. So you wouldn't give yourself execute permissions. The next is the group. So the group that this file belongs to also has readable permissions. They also have writable permissions. They do not have executable permissions. Again, it's a text file. You don't need to execute it. And then lastly is other. So other is everybody else who's not the user and is not the group. We'll talk about the groups in a second, but so other basically stands for everybody else. So if you guys were also on Terra and you looked for this file, which the absolute location of this file would be /home/Dylan/contents of home.txt, you could come here and you could print the contents of this file because it's readable by everybody. You wouldn't be able to write it, so you could not open the file to make edits to it, but you could print the contents of it to your screen. So if I wanted to give everybody access to it, I could use chmod. Chmod is the command for changing attributes. There's two ways to do it. One way is using binary commands, and the other way is using, it's the easier way to do it, and it uses just, I don't know, what's the opposite of binary? It uses like letters and stuff. So you could say chmod, I want to remove writable permission from the group. So, okay, real quick. Also, these two columns immediately after the permissions are the person who owns it. So this tells me that this file is owned by Dylan, and it also belongs to the group Dylan. So each user, when you create an account, has a user group and a username who like it's them, and they also have a group that gets assigned to them. So basically, Dylan just says that this file is just owned by Dylan. But I could change the group ownership and say this file is owned by HPRC. So everybody who's in the HPRC group now has access to the file. You could see the groups that you're a part of by saying groups. And that prints out, it says, okay, Dylan, I'm part of the Dylan group, I'm part of the Gantz group, I'm part of the HPRC group, and I'm part of the Orca group, because I'm a huge advocate for Orcas. So I want to change the, I want to remove the writable permission from the group. So to do that, I'm going to say chmod, chmod, and I'm going to say G, because I want to refer to the group permission, and I'm going to say -x. So that says chmod -x means remove execute, or sorry, -w, group remove the write command, the write permission, and then the name of the file, contents.of home.txt. Enter. I don't see any complaints, so I'm going to say ls-l. And now we see contents of home, and we see that in the second triplet, the W is now missing. So people in the Dylan group could not write to this file. Now this file is only readable by me. So again, that is chmod, and then you could say U, you could say G, or you could say O. That's going to refer to which triplet you want to modify. And then you say plus, or you could say minus. So that says, obviously minus means remove permission, plus means add permission, and then you say the permission that you want to add. It's going to be R, W, or X. I think you can stack them. So you could say, okay, user add, read, write, execute for this file. That is how you use chmod. That's how you use chmod the simple way. There is a more complicated binary way, which is actually, it makes more sense for doing that on a lot of files in bulk. Kind of out of scope for what we're doing here, but that's the idea. This just demonstrates, this is a file, chromosome xy.txt, and 755 is a binary code for permissions. We're not going to go into that, so we'll ignore that one. Here we say O-X, this is saying other, remove executable permissions. And then user and group remove executable permissions, and group give write permissions. Hope that makes sense. Okay, the gedit text editor. So editing text on Linux. On our clusters, we have the gedit text editor installed. Gedit you can think of as Notepad++ if you've used Windows machines. It's just a very basic, bare bones text editor that opens up in a GUI. If you're using the portal, I don't think it'll launch gedit. That might have been fixed by now, but it's a graphical text editor. There's ways to edit text without using graphics. And you would, I'll show you how to do it actually. You can, is it the next slide? Yeah, it's the next slide. Okay, so this last slide, and we're gonna write a really, really quick script So if you're logged into Linux, there's a few ways you could do it. You could say gedit and see script.sh. Yeah, it's not going to open for me because I didn't. It'll open over here. Okay, so in this terminal, I'm going to say Vim is another text editor. Vim is a terminal based. It's all text based, so that you're not going to have any graphics. If you want to use a graphical text editor, I would suggest you say gedit and then the name of it my_script.sh. So now it's taking a second because it's loading some graphical libraries and whatnot, and then it should launch gedit. And then there we go. So, oh, it already exists. Okay, we're gonna remove all this because we've done this before. And now we have, it's really slow because it's running on Terra. And then the graphics are being passed over, so it looks kind of funky, but this is a graphical text editor. It's essentially Notepad++. So I'm gonna say, we're gonna write this script. At the very top of the script, we need to have the shebang. This is the interpreter, which is telling, it's gonna tell Bash to interpret this as a shell script. So just always add that to the top. It's hashtag !bin/bash. And then hashtag HPRC shell script. This is just a comment, pretty self-explanatory. And then my_name equals Dylan. This is creating a variable named my name and storing the value Dylan inside of it. And I'm gonna say echo howdy $my_name. And send that to names.text. Okay, so to keep that, to keep this pretty simple, we're gonna leave it like that. I'm gonna say Control S, which is gonna save this. So all this script is done, has taken my name, taken Dylan, stored it in my name, and then we're gonna echo, which is basically print to the standard out, howdy, my name, and then we're gonna redirect that output to names.text. So I've saved it, I'm gonna close it. I'm gonna go to terminal. And I see a whole bunch of errors or warnings here because gedit launches with a bunch of error warnings. Control L to clear your screen. And when I type ls, I see myscript.sh is green, so it's already executable. So I can just say /my_script.sh and hit enter. So now this script has run. It ran successfully because Bash did not yell at me after I ran it. If I do ls-l, I could see names.text is now created. And if I cat names.text, cat is printing the contents of a file. So you use cat on white files, and that's going to print out whatever text is in them. You use ls on blue files, which is going to print, it's going to list the contents of the directory. And cat the white file, and I see howdy Dylan. So a shell script is just commands that you would enter into the terminal, but you put them in a text file, and then you have Bash run them non-interactively. You just tell it wants to run, and it goes through and it runs in and prints all the commands out, or executes the commands in the order that you have done them. So that is it for what we've got right now. To exit your terminal, you can type exit or log out. Either one's going to work. In this case, I hit exit and then it logs me out. Yeah, so thank you guys for coming. I hope you learned at least a little bit about Linux, the very, very, very basic commands. Again, my name's Dylan and I work for HPRC. This afternoon at 1 o'clock, we're going to be doing the introduction to Terra. So if you are an HPRC user and you're going to be using our clusters and you're brand new, I recommend coming to that primer. I believe it's the same meeting coordinates. And we'll reconvene at 1, and I will give a brief introduction to Terra, how to connect, how to use the software, and just some good information about first-time users. But I really appreciate all of you guys coming, and I hope you have a great Friday. Okay, so we have some questions in chat. Okay, I will read off the questions. 1 second, real quick. I'm going to read off the questions and then give some answers. Just give me 1 second while I okay. So one of the questions we had was, let's back up. Where should I start? Oh, how can I add or remove groups? Adding and removing groups in Linux is more of an administration thing that you would do. So if you're using our clusters, you're going to use Terra or Grace. Adding and removing groups, you would come to us. So you would email help@HPRC, and then we would add them to you. There is a Linux command to do it. I think it's group add. Let's see. I believe, I can just close this out. Pretty sure it's just group add Linux, and it's like one word. Add a new group. Yeah, group add, and then you run it like that. But if you're using like a shared resource like Terra or Grace, you're not going to be able to use group add because you're going to need sudo access. Sudo access basically means run this as an administrator. Okay, and then so there's another question. A user was saying, I'm sure ls-al shows hidden files, but when I use that, I don't see bash history. And so the reason I actually forgot to mention that is the bash history file gets written every time you log out. So if it's your first time logging in and you typed in all your commands, the commands aren't going to be written to bash history until you log out, you close your session, and then the next time you connect, it'll be there. So the reason this user can't see it is because it's probably his first time logging in, so he doesn't have a bash history written yet. But when he logs out, when he closes the terminal or comes back in, it'll write there. And then I think the other one, the last question is, I missed the first 15 minutes of the lecture, how to connect from Windows. Will there be any recording? There is a recording. I think I forgot to start it. It started like a little bit late. It's like the first 5 minutes were missed, but we do have a recording of this on our YouTube. Our YouTube is youtube.com/Texas A&M HPRC. Is that right? Texas HPRC. Yeah. So we have. Oh, okay. Yeah. Rhythm just sent the link. We have these previous versions of these primers recorded. If this one, we'll take a look at this recording and we might upload it there. The slides, however, are available hprc.tamo.edu, events, short courses, right here, view details, and let's see, did they get pushed? Yes, right there, primer fall 21. So that'll be the PDF of the slides that I posted. Of course, talking about Linux kernel programming, we sure could. We absolutely could. So these primers that we kind of have, so I think that would be a little bit too hard to do it. So, okay, sorry. I keep on forgetting that we have people here in person that they can't see the chat. So there's a question about, will we have a class on Linux kernel programming? So the answer to that is for the really, really simple stuff like these Linux commands, we do them in the 50-minute primer format because they can go really quick because it's really, really basic stuff. The more detailed contents and topics, we do short courses, which are 2.5 hour long. Similar to this, I'm not sure if they're going to be held in this room. Previously, we've done them in the SEC, but we kind of just moved to blockers, so we're doing new stuff over here. Those are 2.5 hours long, much more in the weeds, and we go into a lot more detail. Sometimes lunch is provided, the best part. But we don't have Linux kernel programming on the table right now. If you would like to request it, you can send an email and express interest, and I'm sure somebody would assign someone to kind of start fleshing out that. But the courses are based on interest. So if you have a specific interest that you want to hear about, if you send us an email, it really gets the ball rolling on us creating the courses. And we had another question: how will I know which group has access to read and write from the ls command? So the ls command itself does not show you that information. You need to use the -l flag. So again, that's the detailed ls -l. Oh, I logged out on this one already. Okay, over here, this tab. Control L to clear my screen. ls -l. So you have to use the -l to see the permissions. ls by itself just shows you the contents without the permissions. Excuse me. But okay, any more questions? Oh yeah. Yeah, so the question was, could I revisit the gedit comment? So I believe that was referring to, so gedit is just a text editor. There's a whole bunch of different kinds of text editors. Just the ones that we have, the one that we have installed on our cluster is called gedit. Again, it's like Notepad++, really, really simple. In this shell exercise right here, this line beneath it that starts with a hashtag, it's just a comment. So it's like a comment in any programming language. It's going to be ignored by the interpreter. It's there for humans to read it and kind of understand. In this example, this just kind of gives a title: HPRC shell script exercise. In practice, you would use a comment like maybe before a Boolean value, before like a true or false value, you'd say this value determines whether or not something programmatically, I don't know. It's a comment. The top line right here starts with the hashtag, but it's immediately followed by an exclamation point. So if it starts with the hashtag followed by an exclamation point, the interpreter or the shell that you're using when you run it, in our case bash, is going to say, okay, you want us to interpret this set of commands according to bash. And then bin is a top level root directory where all of your executables go. So this implies that bash is a program installed in bin. So if I had Google Chrome installed on Terra, I don't think it is. I think Firefox is installed there. The actual executable program is put into bin. So anytime you see bin in Linux, just think, oh, that's the bin that holds all the applications and stuff. So bash is it's the technical name for the shell, the terminal that we were using, born again shell. It's contained in the bash directory because that's where you put all the software and applications and stuff. And the first line is saying, okay, I want you to interpret this as a bash script. If you said like Python or something, you could say it would interpret it. Oh, okay, this person, like what follows after this is going to be Python code. So interpret it as Python code, that sort of stuff. So the question we had in person was he tried to run gedit according to this slide right here, and it didn't run. And the answer to that is most likely it didn't run because it's a graphical user interface. So the GUIs get sent over port 11 or something. There's a port that has to open. You have to enable X11 forwarding. So to do that, that's the same issue why it didn't run in this terminal right here. When I said gedit and then some file, it said cannot open display because I didn't enable graphics before I logged in. to solve that, new terminal, this is on my local Mac right now. I need to re-SSH. I say SSH minus, for me, it's Y. I think for you, it's going to be X on Windows. And then the name of the place, Terra, Tamil, edu, password. Okay, and then I log in, and I can say gedit some file, and it runs perfectly. No problem. Any other questions? Okay, well, I think that that about wraps it up. Thank you guys for coming in person. I appreciate it. It's the first primer, so we're still kind of working out the kinks of doing an online and in person at the same time. A little difficult. But yeah, so I think that's about it. I'm gonna go ahead and end the meeting now if there's no more questions.